Welcome to the Unit 5 Day 3 video, and today we're going to be focusing on evaluating expressions with negative exponents. We're going to review how to get negative exponents by dividing powers of the same base. We're also going to calculate a negative exponent and simplify. Before, we were talking about what a power is, what a base raised to an exponent means. 2 to the 5th would basically mean I need to multiply 2 by itself 5 times. 2 times 2 times 2 times 2, which by the way is 32. Now if I want 2 to the 4th, I'd have 1 less 2. Only 4 2's this time, which is 16. Now notice the pattern. Remember that to go 1 less power, I could just divide by the base once. The base was 2, so I divide by 2 and I get 1 less power. That's like having 2 to the 5th divided by 2 to the 1st, getting you 2 to the 4th power. And I can continue this process. And in the end of the last video, we talked about what happens when I get all the way down. So if I keep dividing by 2, I start to run out of exponents. Now I'm down to just 2 to the 1st power, which is 2. And if I divide that by 2, we realize that 2 to the 0 power is 1. And in fact, anything that's not 0, any non-zero base raised to a 0 exponent gets me 1. But what happens if I continue to do the division? If I have 2 to the 0 divided again by 2 to the 1st, the subtraction rule would state that I'd have 2 raised to the 0 minus 1, which gets me 2 to the negative 1. But what does that evaluate to be? What is the value of that exponent and that base? 2 raised to the negative 1 is 1 divided by 2, which is 1/2. Now I kind of squished myself in here, but I can go below. I'm just going to skip down here, pretend like that table continues. If I take that 1/2 that was here and I divide it by 2, 1/2 divided by 2 is like multiplying, 1/2 by its reciprocal of 2. To multiply a fraction, to divide a fraction by a whole number, I multiply by the reciprocal of that whole number, 2 over 1. So 1/2 divided by 2 is 1 over 4. So 2 to the negative second would be 1 over 4. You should notice a pattern between 2 to the negative 1 and 2 to the 1st, and 2 to the negative second and 2 to the second. 2 to the negative 3rd would be 1 over 2 to the 3rd, 1 over 8. So the rule for negative exponents is negative exponents are the reciprocal of the positive exponent. In other words, if I have 1 over 2 to the 4th, let me start that over again. If I have 2 to the negative 4th, that is the same thing as 1 over 2 to the positive 4. In general, then, 1 over x to the m is equal to x to the negative m. Let's do some examples. K to the negative 4th. Well, negative exponents simply mean the reciprocal of the positive exponent, 1 over k to the 4th. In letter B, 1 over y to the negative 6 would be 1 over the reciprocal of 1 over y to the positive 6. So that is the reciprocal of y to the positive 6 is y to the negative 6. So if I divide by a fraction, you flip and multiply, which is just y to the positive 6. Now some of you maybe have noticed that instead of thinking about this as dividing, I could just move these numbers to the other side of the fraction. So for example, if I have 1 over y to the negative 6, I can just think of moving that over to the top of the fraction, making it a positive exponent. Let's look at c. I have a to the 8th power, b to the negative 3rd, c to the negative 6th. So that's the same thing now as a to the 8th multiplied by the reciprocal of b to the 3rd, 1 over b to the 3rd, times the reciprocal of c to the 6th, which is 1 over c to the 6th. Now if that is 1 in the denominator, I'll multiply across. I get a to the 8th power divided by 1 times b to the 3rd times c to the 6th. So b to the 3rd, c to the 6th. And you notice that we move from the numerator of this fraction to the denominator when you have a negative exponent. Now I have a number base. What's the exponent on negative 5? The first power. M to the negative 3rd, n to the 9th. Okay, so again, this is going to be negative 5, the first power, which is negative 5, times the reciprocal of m to the 3rd, 1 over m to the 3rd, times n to the 9th. Now remember, I have a whole number times a fraction times another whole number, I should say. It's like having them over 1. So negative 5 will be on the top of the fraction. Negative 5 times 1 times n to the 9th, they're all in the numerator. Numerator, numerator, numerator. And when I multiply, I just go across. Denominator, 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 m to the 3rd. Over here, it's a little bit more complicated fraction, letter e. It's going to be p to the 2nd power. And remember, h to the negative 4th is the reciprocal of h to the positive 4. So that's going to make this h to the 4 go to the denominator. I should use a highlighter here just to code what has been done. So these two things are in the numerator, so I move them now because of the negative exponents. And now p to the negative 3rd will go to the top of the fraction as the positive 3rd power, because the denominator has 2 negative exponents in it. So that p to the 3rd is going to go to the top of the fraction with a positive exponent, and that h to the 6th, h to the negative 6 has become h to the positive 6 on the numerator of the fraction, like this. Now we can simplify this expression by using our product rule, p to the 2nd times p to the 3rd. What do I do with these exponents? When I multiply, I add the exponents if they have the same base. And when I divide h to the 6th divided by h to the 4th, I'm left with 2 more on the top of the fraction. So I'd have h to the 2nd over 1. You don't have to put the over 1 there, but I just wanted to show you that everything in the denominator went away. So my answer, my simplified expression, is p to the 5th, h to the 2nd. So what we were doing in this video, if you had to write a summary, is that we're using the definition of negative exponents to simplify an expression. That's what we were doing. We're just making these simplified because this is a really complicated thing. And so is this fraction over here. Once I was done using my exponent rules, I was able to make them look nicer or more easy to do. Now we're going to combine all of the rules basically that we've learned so far in evaluating this expression. I have, in letter F, 2 times w to the negative 2nd, w to the positive 4, all raised to the 3rd power. Now when I take a power to a power, I multiply the exponents. Notice that the 2 base has 1 as the exponent. When I take everything to the 3rd power, every single base, including the number, gets raised to the 3rd power. A lot of my students will forget to raise this 2 to that 3rd power as well. So my expression becomes 2 to the 3rd, because 1 times 3 is 3. Negative 2 times a positive 3 would be w to the negative 6th. 4 to the 3rd. 4 times 3 is 12. Some people might have been asking in their head, could I simplify this ahead of time? You sure could. Because what's going to happen now when I multiply a power with the same base times another power with the same base, I add the exponents. I have w to the negative 6 plus positive 12. And 2 to the 3rd, since it's a number base, I could actually evaluate that. That's going to be 8. 8w to the 6th power. And that's a lot simpler than what I had at the beginning. And that's the goal. Now, what is simple and what is not is sort of a subjective. It depends on who you are. Some people might like different expressions to look differently, depending on what you're doing. But I think most people would agree that 8w to the 6th power is simpler than what I started with. Over here, I'm multiplying these two together. And notice that there's no exponent on the outside of these, so they stay the way they are. H to the 9th times g to the negative 2nd times h to the 4th. We want to multiply the same powers, or I'm sorry, the same bases is what I meant to say. We want to multiply the same bases, so I'm going to rearrange everything so that the two bases that are alike are next to each other. So it's easier to see that I have h to the 9th times h to the 4th. That gives me h to the 13th power. G to the 1st times g to the negative 2nd would be g to the negative 1st again. And so you can see now that I have a negative exponent. I don't want to have negative exponents in my final expression. So I'm going to use the rule of negative exponents, which tells me that the reciprocal of g to the 1st would be g to the negative 1st. So I'm going to have h to the 13 times 1 over g to the positive 1, which puts it in the denominator of the fraction. You do not need to write the one exponent there. Okay, so we have some bigger ones now. So you have m to the negative 4, n to the negative 12, p to the 7, divided by m to the 2nd, n to the negative 8, p to the 1st. So let's use our quotient rule. We're dividing by the same bases. So here's the first base m, second base p. Sorry, n. Sorry, I skipped to the p. I was looking ahead. P would be the third base. I just do the division. So if I look at this, it would be m to the negative 4 minus 2. I'd have n to the negative 12 minus a negative 8. And I'd have p to the 7 minus 1. So I have m to the negative 6, n. Now a negative minus a negative turns into positive. Negative 12 plus 8 would be negative 4, p to the 6th. Now everything with a negative exponent is going to move to the denominator of this product. So it'd be p to the 6th, and they become the reciprocal of their positive counterparts. Oops, that's supposed to be an n. Let me try again. N to the 4th. And finally, you think of this in one other way. If that didn't really make sense to you, if that was kind of confusing to do all that subtraction, think of it this way. Anytime you have a negative exponent, move it to the other side of the fraction and make it positive. Now notice, what's the exponent on the 4? It's 4 to the 1st power. The 4 does not move around. The 4 will stay in the numerator. But because this is x to the negative 2, that thing is going to move to the other side of the fraction because it has a negative exponent. So now it becomes x to the positive 2 on the other side. And because x to the negative 7 is on the denominator, it's going to move to the top of the fraction and become a positive exponent. Some people like to change all their exponents to positive before they start doing their exponent rules. So I have 4 times x to the 7th, x to the 2. Using the quotient rule of 4 times x to the 5th. So I do 7 minus 2. All right, thank you for watching. Make sure to watch the summary for this video. If you need to rewatch the video at all, you may do so. Have a great day.